In this section, we're going to look at the double angle identities. Here they are. Sine of 2 theta is 2 sine theta cosine theta, and cosine of 2 theta actually has three forms: cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, and 1 minus 2 sine squared theta. Now, initially, this feels like a whole bunch of new equations to memorize, but in fact, this is old information repackaged in a new way. What do I mean by that? Let's look at sine of 2 theta, and we're going to do some manipulations. 2 theta. Well, 2 theta is just theta of theta, so this is sine of theta plus theta. And now we can use the sum of angles formula and apply it to this to see where it takes us. So sine of alpha plus beta is going to be sine of alpha, in this case that's just theta, times cosine of beta, plus cosine alpha sine beta. And again, in this case, alpha and beta are both theta, so theta's everywhere. Well, sine theta, cosine theta, sine theta, the commutative property lets you swap the order, and you see that these are like terms. So we have 2 sine theta, cosine theta. So technically, instead of just memorizing this as a separate formula, you could actually just rederive this every single time. Now, on the other hand, this formula is used often enough that having it memorized separately is also very useful in and of itself. So you have to take make your decision about how you want to do it there. What about the cosine 2 theta? Well, same thing. Cosine of 2 theta is cosine of theta plus theta. And you might remember that the sum of angles for cosine is cosine cosine, so cosine theta times cosine theta minus sine theta. And you'll see that this is exactly the first equation up here, cosine squared theta minus sine squared theta. Okay, well then, where do these other two formulas come from? Now, if you have enough experience from this, you start to recognize, hey, wait, I see cosine squares and sine squares, which means that we might be able to make a substitution using the Pythagorean identity. So again, sine squared theta plus cosine squared theta equals 1. And so sine squared theta is 1 minus cosine squared. So if you plug in 1 minus cosine squared, you'll get that. If you solve for the cosine squared instead, and you get 1 minus sine squared, and you plug that in, and you'll get this other one. So you can see that this is just old information repackaged in a brand new way. And again, it's useful to memorize this not because it's better, but because it's useful. You can always rederive these things from scratch if you had the other formulas memorized, but this is another way that we look at it, and it's useful enough to keep it as a separate topic. Here are a couple applications of the double angle formulas. Determine the value of 2 cosine squared pi over 12 minus 1. So what we have to do with this one is, just like previously, we have to match this up with one of these formulas to figure out which one it's referring to. And so with a little bit of inspection, you'll see 2 cosine squared theta minus 1. So this is going to be 2 cosine squared theta minus 1. And that quantity is cosine of 2 theta. Now at this point, we have to identify the value of theta. We can see right here that theta is equal to pi over 12. And now when we plug this in, we get that this quantity, I'm going to write it in the right order, cosine squared pi over 12 minus 1 is equal to cosine of 2 times theta, 2 pi over 12, which is cosine of pi over 6. And then we think back to the unit circle diagram or the chart. Cosine of pi over 6 is the square root of 3 over 2. Right, so once again, just matching the formula with the one down here, figuring out the correct substitutions. Let's look at the next one. Simplify 4 cosine 3x sine of 3x. Well, we come down here and we look at our formula, 2 sine theta cosine theta. And you can see that there are a couple things. I mean, first of all, you can see that they're swapped in order, but that's not the big deal. However, 4 is not 2. And so we can't immediately just dump this into this equation because this part doesn't match up. So the question is, what can we do about this? And here's where you're going to have to rely on your algebraic experience in order to push yourself forward. When we think about 4 cosine of 3x times sine of 3x, you might recognize that 4 is just 2 times 2. So I can write this as 2 times 2 sine 3x cosine 3x. And here I've also swapped the order to make it match more closely with our formula. And now you can see that this part right here is the exact thing that we're looking for. And so this is 2 times, and come down here, that's sine of 2 theta. Sine of 2 times the theta value, and the theta value is 3x. And so this is equal to 2 times sine of 6x.